everyone. Today we're going over 6.2 notes. Objectives is explain why elements in the same groups have similar properties, and we're going to learn about the four blocks, the SBDF. And the review terms are valence electrons, which is the electrons is the outermost orbital, and they also determine the properties of the atom. Now, one of the things that we did not add on the periodic table that you colored, the SBDF. So you can pause the video and add these details to your table. These rows are the energy level. The energy level for the S block and the P block are the same. So when S is 2S, P is 2P. Now this section is always the level is n minus 1. So if n is 4, then for D it's n minus 1. So if it's 4, then D will be 3, the third level, energy level. Now for F is always n minus 2. So when it usually shows up around here. S is when S6 level, then F would be 4. When 7S, then F would be 5. So two things you need to remember. D is 1 less than S. F is 2 less, but it starts here at 6S. Okay, let's put that. Well, one more thing that you want to remember is S has maximum 2 electrons. We don't need to worry about the orbitals for today's assignments. P has 6, D 10, F 14 maximum number of electrons. You can pause at any time. For notations, the one in front tells us the energy level, the letter tells us the subshell, and the blue number right here tells us the number of electrons. Another presentation is called the box notation, where the 2 electrons are represented by arrows, one going up and one going down, and the one S goes on the bottom. I'm going to work on the mastering concept for your do now. Some were having problems with them. So why do elements chlorine and iodine have similar properties? Let's look at the periodic table. Chlorine, right here, it has the S2 and the P5. So both iodine and chlorine fall under 7A. So they have the same electron configuration. So they would have similar properties. How are the numbers of valence electrons in group A related to group numbers? Valence electrons and group numbers. Now, these are representative elements, 1A, 2A, all the way to 8A. And they tell us the number of valence electrons. So 1A has 1 valence electrons, 3A has 3 valence electrons, and so on. How is the energy level of the atom's valence electrons related to the periods in the periodic table? Okay, energy level are tell us the period. They're the same. So these are called energy level 1, 2, 3, 4, 5. So periods are horizontal and energy level is the same as periods. How many valence electrons in a noble gas? All noble gases have 8 except helium, it has 2. Now the 4 blocks are S, B, D, and F. And in general, what electron configuration has the greatest stability? Anything that has S2 P6 because it adds up to 8. That's the most stable. Determine the group, period, and the block. Okay, group, period, and the block. I'm just going to show you on the periodic table. Group, period, and the block. This is what they're asking for. So we have krypton. So we mark the row right below it. We go to krypton. That's krypton in brackets. That just represents the noble gas, represent every element right before it, all the electrons before it. So it represents 36 electrons. And then what comes next is the 2s, which has 2 electrons, and D1. So 36 plus 3 is 39. And this is just a reminder of all your S, P, D, and F. So 39 electrons, which is element Y right here. Wait. So the group number is 3B, and period would be 5. So group is 3B, period 5, and the block is D. D block. Okay, and the next one, argon is right here, so we go to the row below it. 4s, argon is 18, we have 4s. So we add all the electrons and we get 33 electrons. 33 electron is right here, so it's group 5A, and period or energy level is 4. And it's in the P block. So the group is 5A, period 4, and P block. So helium, you go to the row below it, 2s, 2p6. So you add 2, 4, that's 10. So the group is 8A. I'm sorry, is the block is P, the group is 8, and energy level is 2. So group 8A, energy level 2, and the element is number 10 after you add all the electrons. Okay, I usually like to put a reminder. If you see it as too much, then just get to the last slide. All right, so for this one, NE, we go to the next row. It's 3S, 3P. So the block will be P, and P1, which is right here. But let's add the electron. Neon is 10 plus 3 is 13. So number 13 is aluminum right here. So aluminum is right here. Group will be 3A, and the period will be 3 also. Okay. 3A, period is 3, and it's P block. Categorize the elements in problem 47 as representative or transition. So if they fall into, if they fall into S or P, they're representative. If they fall into D, they're transition. So just look at the last one. It's D, so it's transition. The next one, you look at the last one, P, then it's representative. It's just a quick way of looking at it. And then this one is 262, the last, and that's also representative. P, that's also representative. So when the question is asking you, is it representative or tradition, you look for S and P, that's representative. D is transition. Explain how the element's valence electron configuration determines the place. Okay. Now the valence, the column tell us the group, and it also tell us the valence electrons. The energy level tells us which period. Write electron configuration for the following, okay? A metal in group 5A. So 5A, this bismuth will be the metal. So we go to the neon, noble gas right before it, and that's xenon. So we put xenon in brackets, and then what comes next is 6s, 4f, 5d, and then 6p. So we just add the electrons. The table I give you for the maximum number of electrons. So we have xenon, 6s2, 4f14, 5d10, and then we count the number of electrons for p. So 1, 2, 3. That's how we got p3. Okay, that's for 50A. 50P is halogens in period 3. So period 3, and halogen is all the way down here to chlorine. Now of course you have to know from the tables that you color where halogen is. Okay, so for chlorine, we start with noble gas right before it, which is neon in brackets, and then we go to 3s2 and 3p, but we count the blocks 1, 2, 3, 4, 5. So 3p5, and then we write it down. Neon 3s2, 3p5. Okay, for C, alkali metal in period 2. Alkali metal in period 2 right here. Alkali, from your color periodic table, you know it's 1A. So it's lithium. Lithium, you go to the neon, to the noble gas right before it, which is helium, and then 2s1. Okay, helium, 2s1. Liquid. The liquid at room temperature is mercury, and the neon, I keep saying neon, I'm so sorry. It's the noble gas right before it is xenon. So the next one will be 6s, 4f, 5d. So 6s2, 4f14, 5d, and then we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6s2, 4f14, 5d10. Okay, and that's the end of the slide. I hope that helped with your assignments. I'll see you next time.